In this video, let's understand how to find the domain, vertical asymptote, and the whole, if there's any, of a rational function. In fact, all these three things, they are all related. Sometimes the question might not ask you for the domain, but you still have to find the domain first before you can talk about VA and the whole. Here, we'll do 6 examples, and for the first one, I'm going to provide all the details so you can understand this better, so that later on the examples will seem to be easier. So, what do we do? Find the domain first. And for the domain of a rational function, you just make sure the bottom cannot be equal to 0. So x squared minus x minus 2, not equal to 0. Factor it, we have x plus 1 times x minus 2 cannot be equal to 0. From the first one, x plus 1 cannot be equal to 0. From the second one, x minus 2 cannot be equal to 0. Then, subtract 1 to both sides, x cannot be negative 1. From here, x cannot be equal to 2. Now for the domain, either you write the answer in interval notation or set builder notation. I'm going to write it in interval notation. X is all real numbers except for negative 1 and 2. So we go from negative infinity up to negative 1. Use parentheses to mean that we are not including the number. Union from negative 1 going up to 2. Again, not including negative 1 and negative 2. Union 2 to infinity. So this is the domain of that rational function. Now, after we found the domain, these two numbers are actually going to be the candidates of being a vertical asymptote or a whole. But which one's which though? Let's have a look. If you go back to the original, factor the denominator, we have x plus 1 times x minus 2. And we happen to see that the x minus 2 and the x minus 2 cancel each other out completely, right? So this right here is just the same as 1 over x plus 1, right? We are almost. Firstly, once you see the reduced version, notice we still have the x plus 1 on the bottom. This right here, if you make it not equal to 0, you say x is not equal to negative 1. That will give you the vertical asymptote. So I'm going to write this down right here. VA, it's going to be at x is equal to negative 1. Now, notice earlier I put x is not equal to negative 1 for the domain because you have to set the restriction of the x value that you cannot use. But to write the equation for the vertical asymptote, you write x equals whatever the number is to write the equation for that. Now, how about the whole though? Well, you can probably guess it. It's going to be at 2, right? The other number. But why? The reason is because notice the factor x minus 2 got cancelled out with the 1 on the top, right? So it's no longer being seen at the final result. That creates a hole on the graph. So the hole is going to be at x equals 2. And if this right here is the equation, this is all you have to do. You're done. But now let's investigate why this is the case. So let's take a look at the graph of 1 over x plus 1. And to do so, we will have to do a quick review on the original. So note, 1 over x gives you this and that. This is just y equals 1 over x. Then right here, if you want to get 1 over x plus 1, here's the deal. I'll draw it like this. When you add 1 directly to the x, you are going to move the graph 1 time to the left. So you have a vertical asymptote at negative 1. And that's exactly what we said right here, right? We move the graph 1 time to the left, or do the computation. And you still have the same shape, like this, and like that. And let me just write this down. Y equals 1 over x plus 1. Just like that. But this is not the function that we are trying to graph. We are actually trying to graph the original, right? So there's a difference between this one and the original. So I'm going to put this down right here. The original and this, they are almost the same, except for one number. That number is the 2, because the factor x minus 2 got cancelled. So you don't see that anymore at the final result, right? In fact, these two are only equal under the condition that x cannot be positive 2. We still have to have that. So if you want to graph the original, so let me put down y equals x minus 2 over x squared minus x minus 2. You will still have the vertical asymptote at -1, just like what we said right here. And you will still have the graph going like this and like that. Good. But we have to remember that originally x cannot be equal to 2. So this is how we have to do it. We will go to x is equal to 1, x is equal to 2 right here. We have to go there, go to the graph and erase that. We don't have that point anymore. X cannot be equal to 2. And we have to emphasize that. You don't see this on the graphing calculator, but when you make the graph on your own, you have to emphasize that. You have to exaggerate that. To do so by putting an open circle right here to show that we don't have that point right there. We don't have the value right here. Okay? So this right here is the graph of the original, which is very similar to this right here, except for this particular point. Now, one more thing that we usually do is, once we find the hole, which is at x is equal to 2, we will also need to find the coordinate. We know the x value is 2 already, but how about the y value though? Because you want to find the domain, okay, x cannot be 2, how about the range? We don't have that y value. And in fact, this is like the beginning of calculus, because after domain range, which is like a pre-calc topic, the next thing is, how about the limit? Then that's the calculus topic. So, how do we find the y value for this though? If I plug in 2 into the original right here, guess what? I get 0. And then plug in 2 is 2 squared minus 2 and minus 2. We get 0 over 0. No good. But guess what? Remember, as I told you, they were pretty much equal. So why don't we try to plug in 2 into here, right? Because remember the graph, let me actually change it a little bit and make it similar. The graphs are almost the same except for this point. I can plug in the 2 in here nicely. So when x is 2, right, when x is 2 right here, y is just equal to 1 over 2 plus 1, which is just 1 over 3. So we have 2, and then this particular point is 1/3. And they have the same y value. This is solid circle, this is open circle, but this right here is still going to be 1/3. So the coordinate is what? 2, 1/3. So let me just indicate that. 2, 1/3. Which is really just the same as this right here. 2, 1/3. So take a good look right here. Quick summary. Find the domain first. These numbers will give you the candidates of being a vertical asymptote or a hole. Whichever factor stays remaining at the end, that will give you the vertical asymptote. Whichever got cancelled out completely, that's going to be a hole. And in fact, if you notice, to get a hole when x is equal to 2 is, when you plug in 2 into the original, you get 0 over 0. To get the vertical asymptote, when we have -1, in fact, you get non-zero over 0. Let me write that down. Non-zero over 0. You can try plugging -1 into here. You get -1 minus 2, which is -3, over 0 because we have this factor. Or you can also plug in -1 here, 1 over -1 plus 1, which is 0. Non-zero over 0 gives you the vertical asymptote, and for the hole is like this. And again, it's the original. 0 over 0, originally. Right, originally. And in fact, there's a small detail right here, because not all 0 over 0 will give you the hole all the time. So here's just like one more minute and then we'll move to the next example. For the hole, technically it should be 0 over 0 originally, just like you plug in 2 into here, you get 0 over 0. And you will also have to say, but no non-zero over 0 after reduced. What I'm trying to say right here is that you have to make sure the corresponding factor got cancelled out completely. Because if you still have the x minus 2 on the bottom, that will still produce a vertical asymptote. So be careful with this right here. Of course, the best way for me to illustrate that is with an example. So let's take a look. Okay, for the second one, we have x minus 2 over x squared minus 4x plus 4. So find the domain first. Put the bottom not equal to 0. So x squared minus 4x plus 4 cannot be equal to 0. Factor this, and for this time, we get x minus 2 times x minus 2, which is x minus 2 squared. And we can just say x minus 2 cannot be equal to 0, meaning x cannot be equal to 2. So the domain for that in interval notation, we go from negative infinity up to 2, union 2 to infinity, and that's it. But now, is the 2 going to be a vertical asymptote or a hole? We have to go back to the original and then factor out the bottom. This time, let me write it down as x minus 2 times x minus 2 twice. Have a look. We can cancel out the x minus 2 and the x minus 2. Yeah? And then we get 1 over x minus 2. So notice, we still have the x minus 2 on the bottom after we cancelled. So is this 2 a vertical asymptote or a hole? The answer is that the 2 is going to be a vertical asymptote. Remember, you have to look at the final result. Vertical asymptote at x equals 2. Because if you plug in 2 in here, you get 1 over 0. Do we have any holes though? Well, no. It's not possible to have a hole and the vertical asymptote at the same x value. So in this case, in fact, we don't have any. So I'll just put on none. We don't have any holes. So this is what I was saying earlier. When you plug in 2 into the original, you will see that 2 minus 2 over 2 squared minus 4 times 2 plus 4. This right here, originally, you get 0 over 0. This is originally. Yeah? But if you look at the reduced version, you have 1 over 2 minus 2. You still get what? Non-zero over 0. So after reduced, if you still have non-zero over 0, that will generate a vertical asymptote because the x minus 2 didn't get cancelled out completely. So be really, really careful. That's it. Okay, number 3. Here we have this function. Let's go ahead and find the domain first. Put the bottom not equal to 0. Factor this real quick. We get x plus 4 times x plus 2 not equal to 0. So from here, x plus 4 cannot be equal to 0. From here, x plus 2 cannot be equal to 0. So that means x cannot be negative 4, and then x cannot be negative 2. So notice negative 4 is smaller. So when you write the interval notation, you go from negative infinity, you stop at negative 4 first. And the union, you go from negative 4 to negative 2. And the union, negative 2 to infinity. So this right here will be the domain of the function. For the next example, I'm going to change the blue marker. Don't worry. All right, which one is which though? Well, right here, let's factor it. In fact, we have to factor out both the top and the bottom. On the top, you factor it out, you get x plus 2 times x plus 3. And then on the bottom is what we did over there, right? X plus 4 and x plus 2. And notice, this time the x plus 2 cancel. And we have x plus 3 over x plus 4 left. Okay. Which one is what? Vertical asymptote at x plus 4 still remains on the bottom. So that means the negative 4 is going to give us the vertical asymptote. right? Look at this right here. Done. How about the whole? Do we have any? Yes, the x plus 2 got cancelled completely, and you don't see that on the bottom anymore, right? So we just have the whole at x equals -2. Just like this. But now, what if I ask you for the coordinate of the whole? Well, remember, this and that, they are equal under the condition that x is not equal to -2, right? We have the x value is -2. Let's just secretly plug into this right here so we can find out the y value. So the y value is, plugging -2 in here is okay. -2 plus 3 over -2 plus 4. That's 1 over 2. Yes. So the coordinate is going to be at -2 comma 1/2. Again, to find out the coordinate, do not plug in the -2 into the original, because otherwise you get 0 over 0. Just plug in -2 into here, because you can do so. You get the actual number for that, and that will be the coordinate, the x comma y. Next one. Okay, for the next one, let's go ahead and find the domain first. I told you, new marker. All right, x squared plus 9, make it not equal to 0. But notice, this is just x squared, right? So we can subtract 9 to both sides. So x squared cannot be equal to -9. And if you want to continue, you take the square roots to both sides, cancel, and put a plus or minus. But square root of -9 is not a real result, right? Non-real. If you're talking about the domain, usually we talk about the domain for real numbers only. Since this right here is not possible with real numbers, so the domain is what? There's no number that will make this, that will ruin this. So the domain is just all real numbers. This means the denominator is never 0 with real numbers. So because the domain is -infinity to +∞, we don't have any bad numbers. Do we have any vertical asymptote? No. Do we have any holes? No either. And yes, do we care about the top? No, we don't either. So right here, I will just write this down real quick. For VA, it's none. And then for the hole, again, none. Right? So just like that. All right, next one. Right away, find the domain. Right here, 2x plus 6 cannot be equal to 0. And you don't have to factor, you can just move the 6 to the other side. Becomes -6, and then divide the 2 to both sides. No, things like that. So x cannot be -3. So it's just one bad number here. So we go from -infinity up to -3. Union -3 to infinity. Now the question is this going to give us a vertical asymptote or a hole? Take a look at the original, and we will have to factor it to make sure if it get cancelled out or not, right? So for the top, we can factor and get x minus 5 times x plus 3. On the bottom, we can also factor out the 2. So we can cancel out the x plus 3. And then we will have x minus 5 over just a 2. So what do we say? 2 is just on the bottom, very nice. In fact, if you graph this function, it's just going to be like a line with a hole somewhere. The x plus 3 is no longer on the bottom, right? So the -3 will give you guys the hole. But we do have any vertical asymptote? Nothing on the bottom anymore after reduced. So this right here is just none. And then for the hole, this is going to be at x equals -3. Once again, remember, this is equal to that only under the condition x is not equal to -3. Right? That's it. All right, last one. Let's go ahead and find the domain right away. So the bottom, x squared minus 8x plus 16, make it not equal to 0. Factor this, we get x minus 4 times x minus 4, which is x minus 4 squared, not equal to 0. So this means x minus 4 cannot be equal to 0, so x better not be positive 4. And then we can just write the domain. We go from negative infinity up to 4, union 4 to infinity. Now, which one's that, right? Let's see. Factor out the top, we get x minus 4 times x plus 4, because that's a difference of two squares. X squared minus 4 squared. And then on the bottom, we get that, and I'm going to write it down twice. X minus 4 times another x minus 4. This time, yes, x minus 4, they cancel, but we still see the x minus 4 on the bottom. So this right here, x plus 4 over x minus 4. So what's happening at 4? Because we still have that on the bottom. So that is a vertical asymptote at x equals 4. Do we have any holes? None, right? So it's just a none. What, none? Okay. Just like that. So hopefully this right here makes everything clear for you guys. And best of luck in your pre-calculus and perhaps your calculus as well.